What's going on, everybody, and welcome to part 5 of the data visualization apps with Python and Dash tutorial series. In this tutorial, what I want to do is kind of take the live graphs that we learned about in the previous videos and some of the other stuff and combine it all to create the vehicle sensor data application that I showed initially in the series. So the idea here is that we want to have some sort of application where we can pick things like from either a drop down or maybe a radio dial or something like that, where we can say, hey, I want to visualize these things, and then maybe add or remove things as we want. So maybe not all the time do we care what the oil temperatures of the car are, but then maybe sometimes we do. So we want to be able to dynamically add and remove charts. We'd like those charts to be sized appropriately given whatever the dimensions of the screen are, as well as how many data points we're trying, or how many, sensor data sets that we're attempting to graph at a time. And then obviously we also want this data to be graphed live. So you won't need any actual OBD sensor or anything like that. We're going to just use the dummy data just like we created before. So everybody should be able to follow along. Also, we're not going to type this out line by line. That's kind of silly. Everything that we're going to cover, or everything that we're going to use here, I've already covered at least once in the series, so I just don't want to waste everybody's time on that. There's really only going to be, I think, one truly new thing, a new concept, and that's going to be bringing in outside scripts. But everything else is something we've seen before. So what I'm going to do is I'll put a link in the description to the text-based version of this tutorial. If it's not there or whatever, you can always go to pythonprogramming.net. Maybe. There we go. And then just search for Dash. And here's everything, at least for me, up to part 5. And this is the actual tutorial series here. But if we go ahead and click on part 5, that's where we are. There is no video because I'm filming it right now. Whoa, crazy. But anyways, here is all the code that we're going to just be running through. So you can copy and paste that or whatever. I just want to explain what's going on. So with that, let's go ahead and get started. So the imports that we're going to need are just, I'm pretty sure we've seen all of these. Someone told me that this is dec, not dayq, so thank you. So I'll try to call that dec from now on. Then we've got obviously the graph objects, random, all that. I'm pretty sure all this is what we've seen historically, except for maybe and actually we don't need the data reader because we're not going to be reading in data. I should remove that from the tutorial. Then what we're going to go ahead and do is we're going to define our app and then some starting information. Whoops. So this should be totally familiar to you. And then this data dict here, what this is going to be is basically, this is just going to contain a string to, list dictionary keys and values. So basically what we'll do is when we have I'm just going to do a drop down menu on the app. So the drop down menu, people will choose something called this, but then we actually want it to map to the actual list itself when we do the graphs. So I'm going to use a dict for that. So in the drop down, we're just going to iterate over all the keys in this dictionary, and then to find the values to actually graph them, we just do a lookup by that key. Now what we need to do is go ahead and add in some of the actual data here. So I'm just going to put it here. I think we might get away with defining the dict first like that and then doing this, because these might come as a none. I'm actually not sure, but probably they actually should be up here. So we're going to say the max length is 50 for everything that we're going to graph. Just for the purpose of the tutorial, I think I'm going to change that to 20 just so we can see it shifting over time, but 50 probably makes more sense for this type of an application. But anyway, enough on that. Now what we want to go ahead and do is we need something that's going to modify, so something that's going to just kind of act like the sensor, so something that's going to just read values from a sensor. We're just going to simulate that. So the code for that is just update OBD values. So I'm just going to paste that one in. And basically it just takes in the times, oil temps, intake temps, coolant, RPM, speed, throttle position, and that's it. And then basically all it's going to do is just add to those lists. So we're just going to continue And if it's the first value, it just picks a random thing. Otherwise, we just do a random variance like we've seen before. You don't really need to spend too much time looking up how this function works because you're going to be like probably very few. Like there's really no reason to have this function other than to create dummy data. So don't spend too much time worrying about how that function works. You're probably going to be reading a database or something like that, and hope maybe in the future we'll do. I really wasn't expecting that much interest in as much interest as I've been getting on Dash, so there will definitely, like, this was pretty much the end of the series that I had planned, but since there's so much interest in it, I think we'll pick up some other stuff. So we probably will actually interface with a real database at some point. But anyways, the show must go on. Let's begin with our layout. So there will be a couple new things in the layout itself, but I'll talk about them. So the layout is messed up. Why are we... I'm going to make the text a little smaller now. Let's just go with 12. Just so we can fit it on the screen. Why won't it just come? Thank you. So our layout, as always, starts off as a div. It can get kind of funky, but these are the contents of that main div. So just note that the class name, container, and then the styles here, that's corresponding to the top level, the main div. So what we're saying here is the main div needs to be a width of 98%. We're going to give a 10 pixel margin on the left, a 10 on the right, and then I'm just setting max width to 50,000. There's probably a more elegant way to do this. Maybe you could say max width equals 100%. I'm not really sure. I think that has to be a pixel value, but I don't know. Anyway, there's probably a more elegant way, but without this, for some reason, there's like a default max width in, I think, Dash, which is kind of silly. I wish they didn't do that. But it does tend to make things look prettier if you've got margins on the side. But I'm specifically developing this for a very small screen, like it's a 5-inch screen, and we want all of the screen utilized. So that's why I'm trying to override that. On your computer, it looks fine with or without that, to be honest. But anyways, yeah, so let's see if there's anything else. I'm trying to think. So we are adding in some basic styling here just for the title of the app itself. We're just going to float that left. Then we have the drop down of choices. Note the ID name, because this is the input for our data. The options, again, it's just label and values. So basically it's just going to be it's just the key for the data that's in our data dict. That's it. So then we come down here, and these are just, if you want, you can have default values. So by default, 3 charts will come up when we run this app, but we can remove any of these, and then we can add more. And then if you only wanted coolant temp as the only thing to pop up, you could do that as well. And then multi equals true just means there could be multiple choices in this drop-down menu. Then we have the graphs div. This is going to contain all of our graphs. And then you'll note class name. That's the first time you're probably seeing class name, unless I'm forgetting that we did it before, but I don't think we did. That is the replacement of class in any HTML element. We obviously can't do class because that would conflict with Python's class. So that just gets replaced with class name, and we're giving that the class of row. And the reason I'm doing that is I'm actually bringing in materialize CSS, which is just materializecss.com. I linked to it in the text-based tutorial as well. But it's just a great material design CSS framework that I'm familiar with. That's what I use for pythonprogramming.net and all that. And it has things that just Dash doesn't have for you. Dash is really just there to give you the bare bones of what you might need to build one of these apps. But chances are, if you're really going to build something out, you're going to be using an actual CSS framework besides whatever they make available to you. But anyways, so we will be bringing that in. We have not yet brought that in. That's going to be one thing that you've probably not seen yet, but it's coming. Don't worry. So that's graphs. That's what we're going to update with all of the charts, not just one chart. This will be all of the graphs will be inside this div, this basically div with the class name of row, but ID of graphs. Then we've got the interval. We've got graph updates. So not only do we want to accept user input that is going to pick the charts that we want to show, we also want those charts to be updating live with or without without user input. So the user can't update those charts manually. They can only pick which charts are showing and all that. Okay, so once we've got that, we're ready to actually create the wrapper and the function that will update everything. And we can actually do all this, even though we have like two forms of input/events, we can actually do all of this within one function. And this one, unlike the other ones, this is going to be taking input, it'll be producing output, and it also will take in events. So we're going to have something for everything in this decorator, which is the following. So the output, we output to graphs. Where are we outputting it in graphs? To the children. Then we've got the input, which is vehicle data name, and we're looking for the value. What was the value of that input? And then finally, with events, we are looking for basically that interval, and that's just going to update the graphs. So depending on whether we've got an event or an input, basically our response is always going to be the same. We're going to graph whatever the user apparently wants to graph, and we're going to update that. Basically, we're going to do that every second. So now with the actual function itself, let me just copy that over, paste. This is just the actual start. This doesn't have any of the data. I feel like this one makes a little more sense than the entire code. So I'm just going to post this one first. So basically what this function is going to do is return a list of graphs. So a list of these plotly graphs. The way that we're going to do that is for data and data names, which is going to be passed to update graph via our input. It's going to pass a list of those values. So those are the data names that are getting passed here. So we're going to iterate through those. So for data name, in data names, for each of the values, we're going to say data equals, and then the x will always be wherever we are in the times. And then the data name is going to be whatever that data dict with data name is the key. So the value is the actual list itself, which is getting updated every time we run this update obd values. That's going to get updated. We're not running that yet in this function, just for the sake of clarity. We're going to add that in just a moment. I feel like this is a little easier to follow. Maybe not. We'll see. Anyways, name, we're just calling it scatter. I think the graphs look cool with like a fill underneath them, so this is one of the fill options. And then you can pick a color to fill. So it's just from the bottom up, it just gets filled. You'll see what I mean in a minute. It won't just be like a single line if you don't know what a fill is. Then, once we've created the data, which is pretty simple, it's just your typical scatter plot with a fill, we're going to append to graphs, which is this list of just graph elements. And then we're going to build that dcc.graph element itself, and we're going to encompass that graph element inside of a div. Now this div is what's going to have class name equals class choice, which is what's going to dictate how much space it takes up. So now what I want to do is give you the full function, which has code for those two things. So let me just copy and paste that in. Let me see. There we go. So for updating the lists, we are, again, going to use globals. I would strongly suggest you use, I don't know, a flat file, or you could use a database, depending on kind of what you're trying to do and if you're trying to log historically or not. But anyways, this is the way that we're doing it. So every time this function gets hit, either it will be hit through an event, or it could be hit by adding or removing things. We're going to update the values in this list of things that we're tracking. So we are tracking time, oil temps, intake, coolant, RPM, speeds, and throttle position. But we're not necessarily going to always graph those things, but if we chose to, we'd like to be able to immediately. Then, if the length of data names is greater than 2, which means we want to graph 3 or more things on this graph, this is the class choice that we want. And this has to do with the grid system of, again, materialize.css. So when you have a div that is rows, you can make use of their grid system, and their grid system gives you 12 total columns that you can deal with, and those columns are dictated by the screen size, or you can manipulate those how many columns something takes up by the screen size. So If the screen is small and we have more than three graphs that we want to graph, let's say, if the screen is small, we want them to take up, each graph will take up 12 columns, so it'll actually fill the screen. If the screen is medium sized, like, so this would be like a cell phone size. If the screen is medium sized, like a tablet or something like that, we're going to give it 6. So that means we could have 2 graphs per row. And then otherwise, if the screen is large, we're going to give it 4 grid positions or 4 columns out of 12. So that would mean 3 graphs could show. If we only have 2 data names, then still on a small screen we want it to be 12, but on a medium screen it'd be 6, on a large screen 6. So you wouldn't want to just always say large 4, because then you'd have a bunch of extra space. Like if you only want to graph 2 things, let's use as much space as we can. Again, because I'm going to be using a very small screen, so I wanted to be able to utilize all the space possible. Now if we only have one type, one thing that we're trying to graph, then we want it to go ahead and take up all the 12 columns. So we'll do that. So done. Now, what I would like to do is basically everything else stays the same actually. So we're not really changing anything else. The other thing I'm modifying in the actual Go layout itself, in the graph layout, that graph objects, we're doing the X and Y axes, changing those dynamically. You've already seen that before. The only thing that's really changed here is that we're using the dict to get those values, but it's the same concept. Then we can modify the margins here. I did that just to make things as tight as possible. Again, I'm trying to get as much on screen as possible. I don't want a bunch of useless spacing. On a big screen, spacing looks nice. We like that. White space is really cool these days. So anyways, but this was meant for a small screen, so I wanted to set those margins small. So this is just how much margin on the left, right, top, bottom. And the reason why we have so much margin on the left and on the top is because the top we have titles, so we have some title text that's going to explain what this chart is. As you'll see, where did I put title? Oh, right under here. So anyways, we want to show that title text. So title text, these margins are just for the chart. They don't include the text that describes the axes or the title, which again, kind of silly, but okay. So, and then left is for the axes labels for, like the y-axes. We want to be able to read those, so that's why that's there. I don't really care that much about the timestamps because it should be updating live. So those are actually getting chopped off because of these margins. Anyway, other than that, animates true. I don't think there's really anything else here that you wouldn't be familiar with. But if I'm skipping over something, please do feel free to ask in the comments below. Okay, now what we need to do is we need to bring in external CSS and JavaScript. So if you're familiar with coding in HTML or, well, yeah, if you're familiar with building front end stuff, you frequently include JavaScript or CSS files that beyond what are the CSS that you just enter in strictly into the HTML. So the way that you can do that with Dash is actually pretty darn simple. So let me just paste that in. So with you'll just specify some list if you want. There's a few ways you could do this, but I think this makes the most sense. So for external style sheets, you'll just throw them in this list here, and then you'll iterate through them, and then you just append them to your app, and it'll handle actually putting it in your app for you. And then the same thing is true with any external JavaScript. So with Materialize, to move things around as you dynamically resize or whatever, you also want to have their JavaScript. So you can bring that in as well. Finally, to run the app, it's just if name equals main, run the server. The last thing I want to bring up, I should probably run this first before I bring it up, because everyone probably just wants to run it, and if there's some error, people are not going to be happy. So let's just run this real quick. 127, let's open it up. It says loading. Can we bring it over? Sure can. Okay, cool. So as you can see, it shows 3, but if you were to like squish this up a little bit, you'll see that the other one kind of popped down here, and if we continue to squish it, it'll just be 1, right? And then we can full size that again. And then what if we actually get rid of like intake temps? You'll see, okay, they go and fill the screen again. And if we get rid of oil temperature, boom, coolant temp, fills the screen again, and that's all thanks to Materialize CSS. And then we can actually add stuff in, and again, the same thing starts to happen again. Interestingly enough, I did find a little bit of a bug with this whole thing. So like the titles of these charts can get kind of finicky. So let's see if I can get away with this, showing you guys live. So if rather than having 3 things, let's say we only have 1 chart. So let's just do coolant temp. Let me save that. Let's see if this updates. Sometimes it'll do this for me. We'll see. No, it didn't want to do it. Darn it. Oh, I bet if I refresh though. Yeah. Okay, so now we're starting with just 1 chart. Now watch the title. So I'll add speed. So you'll see speed's title is perfectly in the middle, right? But coolant temp is messed up. And then we can continue adding stuff like intake temperature and all that. So that's one bug I've found with this whole thing. And I don't know if that's because we've got some CSS conflicts going on or what. If someone can figure that out, I'd love to know. The other interesting thing is if I X out of coolant temp, everyone disappears, and you can see dash is like really flipping out right here. But I can add something. Oh, usually in the past I've been able to do that. But I guess if I clear it out maybe. Oh, okay, now I add something and it's back sort of working. But yeah, for some reason that just really screws up dash. So that's still a couple of bugs. I'm trying to figure out what causes that. But again, the same thing happens as you go through. You actually, what I'm finding you have to do is if you want to get rid of stuff, you have to like start at the end, which is kind of screwy. I'm sure I'm just doing something wrong in my code. So yeah, if someone knows what's going on there, feel free to let me know. The last thing I want to leave you guys with before I break here is the Plotly documentation. So actually 2 things. One is the dash documentation, then one is Plotly. So one thing you definitely want to look at is the core components for dash. Make sure you go through this. So this is something that you would use a lot from a CSS framework. But you'd always want to check to see if it exists already in Dash, like the drop-downs. So drop-downs are things you'd commonly see in other frameworks, but Dash has them built in a very special way. So you'd want to use their drop-downs because they give you much more functionality than if you were to create your own. So for example, yes, the drop-downs. And then they've got some examples. They've also got sliders. They've got a range slider where you could pick different things on both sides. Obviously the input, which we've already seen before, a text area, which we haven't checked out, checkboxes, which we also haven't checked out or really used, radio options. They've got buttons, which obviously could get more and more interesting. Data picker, so like this is just a calendar, for example. Data picker with a range, so start and end calendar. And then they've also got markdown examples. Then they've got things like interactive tables, and then an upload, which is a pretty commonly used thing, especially in data analysis. So if you create an app or something that reads CSVs, you want to be able to upload them into your app really quickly and easily. That's going to be super useful. Tabs, again, this is something that's super common in CSS frameworks. It's here for you. Same thing with the tables. And obviously graphs. Anyway, so go through that and just make sure you look at the updates from time to time just to see if they've added anything. And then the other thing finally I want to bring your attention to is just the Plotly documentation, because everything here is Plotly. So things like I'm trying to go down here. Let's see. Connecting to databases, for example. Reading from CSV files. Reading from MySQL, reading from BigQuery, Salesforce, all this stuff. They've got that for you already. Make sure you're not just repeating something they've already done. Also report generation, so creating PDF reports. You can also do HTML reports and all that. Anyway, that's all for now. Like I said, I'm trying to think of another maybe a larger application to build. People I know were looking for something to know how well does Dash scale with more and more data and all that. So I'm planning to kind of look more deeply into that, also integrating it into an existing website, making multiple page apps either with Dash or with Flask with Dash embedded and all that. So I'm still going to keep poking around and stuff like that. Not sure when that'll come out or anything like that. Like I said, I was kind of caught by surprise by how popular this series was. I just didn't think people were going to care as much as I cared about Dash, but it is pretty cool. Anyways, if you have questions, comments, concerns, whatever, feel free to leave them below. Otherwise, I will see you in another tutorial.